Okay, this one, the given information looks really short, but it actually tells us a lot because it says BD is a perpendicular bisector. Those are two different things. So let's first deal with the perpendicular part. BD is perpendicular to AC. So I know that that's a right angle and that's a right angle. Then the bisector part means BD is bisecting AC, so it's cutting AC into two equal pieces. So I can mark those two are congruent. And then beyond that, it looks like they share this side, so we can use the reflexive property. So we have two sides and an angle. It is a right triangle, so you can see if you can use HL by drawing an arrow from the hypotenuse, or from the right angle. It'll be pointing at the hypotenuse. You'll notice that is not marked, so we are not going to use HL. Okay, we do have two sides and an angle. The angle is between the two sides, so we can use side, angle, side. So for step 2, we have to deal with each of these parts individually. So let's start with the perpendicular. Because it was perpendicular, it made two right angles. So angle BDA and angle BDC are right angles by the definition of perpendicular. Okay, we didn't say they're congruent, we just said they're right angles. But for step 3, we can say they're congruent because all right angles are congruent. Okay, we just said that two angles are congruent, so I can cross off the A. Now let's deal with the bisector part. We marked these two congruent pieces because of the bisector. So segment AD is congruent to segment DC by the definition of bisector. Okay, and that means we just said two sides are congruent. We can mark off an S. The last side is the one they share. So BD is congruent to BD by the reflexive property. So I can mark off the last S. Everything's marked off in my to-do list up here, so we can use the prove statement to say the two triangles are congruent. By SAS.